In the last video, we have seen the working of arithmetic operators, unary as well as binary. And unary operators works with one operand and binary operators works with two operand. In this video, I'm going to discuss about the operator precedence and associativity. This two topic is very important, very much important for an expression which are based on or which contains more than one arithmetic operators. Okay, so what we have discussed in the last video, from that we're going to continue in this lecture, right? Okay, so we have already seen there are two types of arithmetic operators. One is unary and another one is binary, right? Okay. Now, let us take an example to understand what do you mean by operator precedence and associativity and why it is important, right? Okay. So, let's take a expression here. Suppose we want to solve A equal to B plus C in C programming, right? Mathematics rules we know in C programming. So, it is very straightforward. You may consider that say B equal to I have 3 and C equal to I have 4, and both of them suppose declared as integer, and when you perform this, definitely the result of two integer will also produce an integer in case of addition. So simply that values of B will replace here and values of C will be replaced here, and they'll produce a value as equal to 7. Very straightforward. But what if suppose I want to calculate A in different way? Suppose I want A equal to B plus C and multiply by 3. Now look at this expression carefully. In this particular expression, it contains two different binary arithmetic operator. One is addition, another is multiplication. So now main question is here that compiler will perform which operation first? Will compiler consider first B plus C, and result of B plus C, suppose if I consider it is D, and that result will be multiply with 3, or compiler will first perform C multiply by 3 and result of this will be added with B. Okay, to answer this question, we need to understand operator precedence. In another term, operator precedence, we also can call it as a priority. Means which part of the expression or which arithmetic operation will be evaluated first. So priority or precedence will inform the compiler or help the compiler for what purpose? To take a decision about an operator. It can be unary and it can be binary. In this example, I have taken both of them as an binary arithmetic operator. So to take a decision about an mathematical operator to be evaluated first. So to understand how compiler will take this decision, we must know that what are the precedence of each and every operator under unary and binary. Okay, so let me write it here for you. So I'm going to write from top to bottom. So operators with higher precedence means that part of the expression will be evaluated first. I'll keep it on the top of the table. So very easily we can also remember them. All the unary operator, so let us write here, this is unary plus, unary minus are higher the priority, followed by increment and decrement of post variant, and then followed by increment and decrement of pre-variant is the priority. So that means in unary operator, arithmetic plus, unary plus and unary minus will be top of the table, then followed by post increment and decrement will be evaluated, and at last our pre increment and decrement. But what about the binary arithmetic operators that we have? So these operators also falls in this table. Next, multiplication, division and modulo, or we can say the remainder, have the priority. They are lower with compared to the unary arithmetic operators, and at last we have other two, that is binary addition and subtraction. Okay, so this is the order. Okay, this is the order. This is the lowest and this will be the highest. Okay, so there might be some doubt in your mind. Okay, fine. So based on that operation will be performed. But if we look at this particular category 1, category 2, category 3, and each of these categories have more than one operators. Here we have 3 operators. Asterisk are used for multiplication, front slash are used for division, we have already seen in the last video, and percentage is used for modulo operation, we called, or we also can call modulus operation. So what if suppose there is an expression integer result equal to, we want to evaluate 5 plus 3 minus 2, which one will be evaluated first, which part of the expression will be evaluated first. So for this we are going to first refer the operator precedence table. So if we refer the operator precedence table, we found that this particular expression have 2 operator with equal precedence, plus as well as minus. So now how this compiler will take the decision, first 3 minus 2 will be evaluated first or 5 plus 3 will be evaluated first. So whenever if you have an expression when more than one operator are with same precedence, then another concept need to be applied. The second concept we called associativity. Okay, so what do you mean by associativity? When it will be applicable? Remember, associativity will not applicable always while solving a mathematical expression. Associativity will come into scenario when a mathematical expression have more than one operator with equal precedence. For an example, you can refer this, or if you take another example, like suppose we want to calculate result equal to 5 multiplied by 3 divided by 6, suppose, and again plus 12 and then again divide by 4. So here in this expression you can see this one and this one, they are equal in precedence. So here compiler cannot solve this expression by only considering the operator precedence rule or by considering this table. So in such case associativity will be applicable. Remember, associativity are 2 types. One, the evolution of the expression will follow the order from left to right, or the evolution of the expression will follow the order right to left. Okay, so if I just take a simple example, the previous one, where I have written result equal to 5 plus 3 minus 2. So in this case, it will follow the order left to right. So remember, in our precedence table that we have written these two different categories of operators, right? These are the unary and these are the binary. Remember, this unary plus and unary minus along with post, increment and decrement, they follow the order right to left. Sorry, they follow the order, yes, right to left, right to left. Okay, along with this pre-increment and decrement as well, right to left. And the operators require two operand, that means binary arithmetic operators, they follow the order left to right, left to right. Okay, I hope that discussion is clear. Okay, so in short, you can easily remember left to right are the binary category and they are below in the table, and right to left are the unary category, they are top of the table, right? So in this case, both the operators are in binary category, so they follow the order left to right, left to right. Okay, so it means what? It means 5 plus 3 will be evaluated first, so it will give us a result of 8, and then subtraction will be calculated, and 8 minus 2, that answer will be 6. So this is the very simple arithmetic expression that I have considered, right? So now let's move to the compiler and demonstrate this topic with couple of examples and try to understand the concept, right? Okay, so let me declare just two variable here, a equal to 5 and integer b equal to 6. And now let us calculate result r equal to, I want to perform a plus b and then minus 2, and then let us print the result r. I am going to consider percentage d. Okay, you can have a short integers. Okay, I'll not going to overlap with the sign, no mismatch, so percentage d can take care signed and unsigned both. So I'm going to handle all the output in a percentage d format, right? So now I'm going to print the value of r. So let us see how it is works. So see, the result is 9 here. So simply if you apply, okay, if you apply just simple Bodmas rules that we know, okay, Bodmas rule of maths, same result you will get here. Same, a plus b minus 2, so they are in equal in precedence, so we'll follow the associativity. So in associativity, the order will be left to right because it is arithmetic binary operators. So here a plus b, what it will give me, 5 plus 6, I'll get 11, and minus 2, and the answer will be 9. So you also get the answer is 9. Okay, so now let's mix couple of different types of operator. Okay, let's mix. Now here, if I just want to add unary minus, okay, unary minus, now what will happen? So if you recall the table, that list of operators and precedence that we have listed, unary operators are top of the table, right? So that means this particular expression will be evaluated first. Now please remember one very important point. While you considering or while you solving an expression with unary minus, sometimes I found that students are confused with this. When you use unary minus, first time when you evaluate, that the result will be here minus 2. Next time onwards, do not consider the sign. Consider minus 2 as a whole value. Okay, initially this contains minus is the operator and 2 is the operand, right? So as part of our precedence table, now it is clear to us that this particular part will be evaluated first. Okay, so now what will be the value? Value will be minus 2, and this particular sign, we know what is happening in the maths, plus and minus, when you combine together, outcome will be in minus. Okay, so just you can rewrite this expression here, replace the value of a by 5, replace the value of b by 6, and place the value minus 2, and this plus and minus also become minus 2. And now again you can see there are multiple operators with same precedence, so follow the order left to right. So particularly this part will be evaluated first, and next this part will be evaluated first, so it will be 9, so minus 2, the answer will be 7. So let me just execute, you can see the result. Result is 7. Okay, I hope you understand this mixing of this unary and binary operators, right? Okay, so now let's make this expression a little bit more complicated now. So let us use other unary operators that we have. We have plus plus a, right? Now I have applied pre-increment. Okay, pre-increment. And let me just add another one, b minus minus. Okay, now I have applied also post decrement. Okay, so now let us see how this expression going to be evaluated. Again, as per the table, we have here two unary operators, so they are in higher in precedence. Okay, so if you just recall the table, we found that post increment and decrement is higher in precedence as compared to pre. Okay, now I post increment. So now if I just want to replace this value, okay, so it will solve this one first, right? It will solve this one first. So what I have written here, do not replace the values in other part of the expression, because you need to take care when you are going to use pre and post either increment and decrement. You need to solve one by one. So now this one is post. So in post we know that that particular expression will be replaced by its current value. So here current value b is 6, and then the value of the operand will be decremented by 1. So after this part of the expression, b is right now 5. Okay, so now let's continue. Now this part is resolved. Now further we have plus plus a. So what is the value of a right now? The value of a is right now 5. So this one is the pre-increment. So we know from the definition of pre-increment, value of the operand will update by 1 or increment by 1, and it will consider the new value in the expression. So if I update the value of a, so a will become 6. So 6 will be placed here, and this will be our current expression. Now we still remains with two other variables. We need to replace them. So let's replace them now. We need to consider the final values, not the initial values. So these are our initial values. Okay, now these are our final values because we have executed minus b minus minus and plus plus a. So what is the present value of a? 6. What is the present value of b? Also 6. Now it is very straightforward. We need to follow the order left to right. So it will be 12 minus 2 plus 6 plus 6. So the 12 minus 2 is 10 plus 6 plus 6. So 10 plus 6 16, 16 plus 6 22. So let us check the result by execution of this code. Okay, we get the value as 21. What is the mistake we have done? Okay, here b equal to 5, right? So I put b equal to 6. This is the mistake I have done here. This one, just look at here. Here I consider the initial value. Although I have marked it is the final value. So instead of 5 here, I just put 6. This is the mistake. Okay, our calculation is correct. So now if it is 5, so 6 plus 5, it will become 11. Okay, so 11 minus 2, so it will become 9, right? And 9 plus 6 is 15, 15 plus 6 is 21. So we get the correct result here. Only just I consider the misplaced value. Okay. Okay, so now let's continue. Let us take another example here. Another example. Okay, let me just going to print their values as well so that you can understand, right? So I'm just now taking here a plus plus, okay, plus um, then suppose b minus minus, right? Okay, fine. We are only considering now unary and combined with the binary addition. Along with the r, let us print the value of a as well so that you can understand this. Done. So let's execute this. Okay, so now let us evaluate the expression based on the knowledge that we have. Okay, and let's try to find these values. Okay, so again, so if I just let us just write this expression here, r equal to a plus 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 b minus minus. Fine. So this one is our increment, this one is our decrement. Both the version is post. So it is very easy. Post version is very easy. Directly use the current value. Okay. So if I replace their value now, a plus plus, so a is 5. So use the current value. Update the a. So a will become 6. So a will become 6. And now plus b minus minus, current value is 6. And because of minus minus, b become 5. B become 5. And the final result will be 11 and a will be 6, b equal to 5. So here you can see a is 6, b equal to 5 and r equal to 11. I hope you understand, right? So whenever an expression contains multiple operators, first check the precedence. If there are different precedence, so follow the order of execution as per the precedence. And if there are same precedence, follow the order of execution based on the associativity. So now let us take an example of associativity. We have done with the precedence part. We'll see, we'll come up with more example. Let's just continue with the associativity. So now I am doing a plus b, right, multiply by 2, okay, then divided by 4, or suppose let's take a large value, 20, yeah, 20 divided by 7, okay, modulus by 3, okay. So, and we're going to print AB, there will be no change because this time we have not done any pre or post. We're simply going to print R because other two values will remain unchanged. Okay, so now let us, this time we'll evaluate first and then we'll compile the code. Okay, so let us evaluate based on the information that we have right now. So this is the expression. Now first check the expression. Okay, check the expression. This expression contains operator with different precedence or same precedence. Okay, if I compare these two different, okay, go further, do not start evaluating, check the complete expression. This one is same precedence and this one is also same precedence. Oh, so now we need to handle this part because as part of the precedence, this is higher, and this part is lower. Got it? Now, as per the table, they have the same precedence. They are the same precedence. So, what rule we should applicable now? Even if you follow mathematics Bodmas rule, you will follow left to right. So, as per our associativity, we will also follow left to right. Why? Because multiplication, division, and modulo, they are same precedence. At number 4, you can see in the table, and they follow left to right associativity. Okay, so what is associativity? As we have just find the solution, if an expression, you can also note down the things, have multiple operators with equal precedence, then associativity need to consider to solve the given expression. Right? So we need to note down these stuffs, right? Okay. So now here we know left to right, right? So let us just follow the order left to right. So we are not using any pre or post increment, so we can replace the values directly. A is 5, B is 6, okay, multiply by 20, division by 7 and modulus by 3, right? Okay, first of all, if I follow left to right, this part will be evaluated first. So 6 multiply by 20, that will be 120, then divide by 7, modulus by 3, then we have 5 plus this one, so 120 by 7, the result will be 17. Okay, 1 will be the remainder. Okay, fine. Yes, correct. 5, fine. And now last is modulus. And now if we solve, this part need to be solved first. So the remainder will be 2 and the answer will be 7. So let's execute the code and see the result. Answer is 7. Got it? Now I hope this idea is clear, but our topic is not over yet. Now we're going to introduce another concept. So let's go back here. Now if you see the whatever the order of execution, it is followed as per the operator precedence table mainly. Okay, whenever there is a tie, then only associativity come into scenario. Okay, now C programming says that, not only C, all other programming language says that it is not mandatory that we need to follow the precedence table for order of execution. Okay, it is not mandatory. Order of execution. Based on our requirement, we can also change the order of our execution. We can also change the order of execution. But now question is that how we can change the order of execution? How? Can we change the rules of mathematics? BODMAS rule? No, we are not going to change those rules. Compiler also follow those rules. We can, based on our requirement, okay, based on our requirement, we can change the priority of a part of the expression by using parenthesis like this. So if I consider this expression a plus b multiplied by c, definitely b multiplied by c will be evaluated first. But if I do the parenthesization like this, then compiler will follow the order of parenthesization. So it will be the consider first a plus b will be evaluated first and followed by the result of a plus b will be multiplied with c. Okay, so let's test it in our compiler, online compiler. Yeah. Okay, so now if I take the same one and I want to change the order now, okay, now see the change of order I going to change, the precedence order I going to change, the execution order I going to change now. So now there might be one question in your mind, which parenthesization will be solved first? Will this one will be solved first or this one will be solved first? Okay, so check carefully. Based on the operator, if the required operand is present, you can easily solve. So normally again the order will be followed left to right. Okay, so let us solve. So what we have written, r equal to a plus b. So let's write it here. Okay, so if I follow left to right order here, so 5 plus 6 will become 11. Now 7 modulus 3, okay, 7 modulus 3, okay, let's write 7 modulus 3 here. The next one we're going to solve. Okay, 7 modulus 3, we need only the remainder, so remainder will be 1. Okay, now there are two operators remains, one is the multiplication, another is the division, so there are same precedence, will follow left to right. So 11 multiplied by 20, answer will be 220, and divided by 1, so any number if I divide it by 1, answer will be the same number. Sorry, 220, right? I just by mistake just erase, so let us just execute and see. So here you can see the result. Whatever the result we have obtained, we get the same result here. So it means by using parenthesization, we can modify the precedence of the operator as per our requirement. Okay, so these are the fundamental parts that I have explained regarding the associativity and the precedence. Okay, you need to remember all those things while you're going to building the complex application. Now, one very important part in C programming, specifically in C compiler, whatever we have seen, if I follow the rules of operator precedence and associativity, it is okay for us. Now, sometimes we found that there might be some expression. For an example, suppose I am going to write b equal to a plus 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 a. Now look at here carefully. Previously, whatever the expression we have solved with the increment and decrement operator, we have taken two different operand. Now here post increment will be applied over the operand a. Similarly, in the same time, in the same expression, pre-increment also going to be applied over the same operand. So if we just follow the precedence table, this one is the higher in priority and this one is the lower in priority. Okay, so based on the table, let's try to solve this. Okay, and let's see how compiler behaves. Okay, so let me just refresh here. And now let's add the same one, a plus plus, what I have written, yeah, plus. Please do the spacing between the operator and operand properly so that compiler get the correct syntax while evaluating. And I have written a plus plus. Okay, now let's print a also along with r. So let us follow the basic concept that we have learned. Okay, and how is the same way compiler is also going to solve the given expression, or it's going to solve the expression into different way. Okay, so now here a plus plus and plus plus a, which one will be evaluated first? Okay, which one will be evaluated first? Let's see. So if we follow the table, we know that this one is the higher in precedence. Okay, so let's just replace the value a plus plus. This is post increment. So post increment will use the current value. So current value is 5 and update the value of the operand. So now immediately a becomes 6. Okay, then plus. This is pre-increment. It will update the value of the operand. So what is the value of the operand? 6. So 6 becomes 7 and use the update value. So here we are getting r equal to 12 and the value of a is 7. Okay, so let's see what compiler evaluates. See, we get the value r equal to 12 and a equal to 7. There is no issue. Correct? Okay, now let's do the reverse again. Let's do the reverse. Just to refresh this page. Yeah. Now suppose if I do plus plus a and a plus plus. Okay. So if we follow the precedence table that we have just discussed, okay, will it be considered the same way or different way? Okay. As per the table, post increment is the higher in precedence. Okay. So R equal to, if I just evaluate A plus plus, so A will become its old value will be put here, and A will become 6, and here if I just use plus plus A, so it will become 7. So answer will be again as per our theoretical concept is 12 and 7. So let's execute and see. No, now see the value is not 12 anymore, value is 13. Oh, because as per the table, okay, as per the table, we have seen that post increment operator is higher in precedence. So if post increment operator is higher in precedence, so this part should be evaluated first. So because it is post, it will take its current value. So current value is 5, it is updated to 6, fine, and it is our pre-increment. So pre-increment will update first, so 6 becomes 7, and it will use that update value. So 7 plus 5, it will become 12, but we get the answer 13, but as value is correct, we are also getting 7. Okay, so now let's change the order. If we follow this way, will it get 13? So let us try. So this is A plus plus A, it is pre-increment. So in pre-increment, A will become 6, so it will consider the value of 6 here. Plus, now again A plus plus, so A is here post-increment, so it will use the current value. So current value is 6, and A will update it to 7. So if I follow even this order, left to right, or even I follow right to left, every time I am coming to the conclusion that value will be 12. But here, okay, if I just seen that result is 13, not 12. So I am now confused. Which order is actually is going to follow? Yes. So remember one very important part with respect to C programming, the behavior of increment and decrement operator is undefined when same variable get updated multiple times in a same expression. Totally the behavior is undefined. Okay, please remember this very much important concept here. The behavior of increment and decrement. Here I am using increment. Same case happened. Suppose if I write b equal to minus minus a minus a minus minus. Okay. So here we cannot predict the answer because C doesn't define the order of execution for increment and decrement operator when it is applied over the same variable multiple times in a same expression. Remember this very important concept. But we can easily evaluate when this operator is come with only once occurrence in each expression. I can easily calculate this. No problem. It is defined because here both are two different operand, no issue. Even though you can also do this. No problem. You can even mix them. Yeah, you can do this. No problem. Why? Because two different operand is appeared in a same expression. So compiler can easily calculate. That is the reason here When previous case we calculate the value, previously we have written this r equal to a plus plus and plus a. Okay, so let me just show you again. If I just rewrite this after this line, and let me just use another variable, integer k equal to a plus plus a. Okay, fine. And now let us just print k here again, and let me just update with the b also, same value, b and b. And now if I just going to update the value of b and k, and let's see their behavior. Okay, let me refresh the page. Okay, and evaluate first manually. Okay, again let us evaluate manually and see their behavior. Okay, so as per our discussion and the knowledge we have, so this expression, if I solved, r equal to, if I follow this left to right order, even though we know, so if I, let me just go with the theoretical concept, this post increment is the higher in precedence, right? So r equal to plus a, fine, plus a plus plus. What is the value of a? A is 5, and due to the plus plus, what is the value of a become 6. Okay, so now let's solve it again. R equal to, what is the present value of a? 6. So plus 6, it will become 7. 7 plus 5, and a becomes 7. So here as per our calculation, r will be 12 and a will be 7. Okay, so now let's solve this. So if we know that the post increment is higher in precedence, right? So now k equal to b plus plus. What is the b's current value? 5 plus, because of b plus plus, b becomes 6. Okay, then again plus b. Okay, so let's calculate it again. Continue. R equal, sorry, not r, yeah, k equal to 5 plus b. What is b? B is 6. So 6 becomes 7. 6 becomes 7, and b is also get 7. So here in either case we get the answer 12, even though I follow left to right or right to left. So now execute the code and see the result. So now see here, the second version that we have calculated, we get the answer correctly, k equal to 12. Okay, but the first variant we did not get the answer correctly. Okay, here also we get 13, but it is 12. 12, we get 12, it is give me 13. Okay, because the behavior is not defined. Any order you can take, any order. So now suppose if I follow this order, okay, so plus a and r equal to plus a plus plus. So what is the value of a right now? A is 5, right? And due to the plus a becomes 6. Okay, so plus a, it will become 7 and 5. So see, anyway I get 12, I did not get 13. I follow left to right now and right to left now. Previously I followed left to right. I am not getting. But here I am getting somehow the correct result. So if your expression become more complex, arithmetic increment and decrement, it will make your life miserable. Sorry. You cannot calculate the value. Even it depends on the compiler. Some compiler will give some value, some compiler will give some other value. So as per the standard, it is suggested that, okay, what it is suggested that do not, okay, right, do not mix increment and decrement operators. Do not mix. Simple statement. Do not mix in a expression. Okay. in my 15 years of coding experience, I never came across such project, okay, or such coding scenario where I need to mix them. If you need this, suppose if you need this now, okay, let me just scroll down. If I just take an example here, suppose you need to calculate this a plus 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 a plus plus again minus 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 a plus plus. Okay, suppose you need somewhere you need. So calculate this one separately, calculate this below separately, calculate this below separately, calculate this below separately. You know which part you want to evaluate first. Suppose if you want to evaluate first, okay, so let's take some temporary variable t1, okay, temporary variable t1 and perform here a plus plus, okay. So this one again, so take temporary variable, again you just do a plus plus. Now again another temporary variable, do this. If you want this order, so this way you can do, and then replace this thing with the sorry, excuse me, replace this thing with this temporary variables that we have declared here. Then you, whatever the output you will be getting, compiler also going to produce the same output. Okay, so I think this is sufficient for the now operator precedence and associativity for the arithmetic operators. Our operator topic is not over. Okay, only arithmetic part I have covered. Please comment whenever you feel that if you need more examples. Okay, practice on the compiler with the different types of operators and operand to understand their order of execution. Okay, in real project we do not mix the operators, we do not make our life complicated, we keep our expression simple, but these are we need to understand. Whenever I believe that whenever you learn some programming language, you have to have good background of theoretical concept of the all the features of that programming language, okay, so that you can use them whenever they necessary, right? So please do like my video. If you like my content, like my video and share with your friends, and please do not forget to subscribe. Next topic we're going to discuss about a different data type, that is bool. We'll discuss in the next video, because without discussing this particular data type bool, I cannot discuss two other operator, that is relational or conditional we sometimes say, along with the logical operators. Okay, so next video will be very short, max to max 10 minutes, next lecture. And once I finish that bool data type, which was introduced in C99, so you need to look your compiler, which compiler you are working. If you are working on C89, the bool will not support. You can continue with the integer. I'll tell you both the process. Here GDB compiler, by default it will be C99. Okay, and thereafter once I finish, we'll move to the other category of the operator. And once we finish this relational and logical operator, we are ready to solve some problem, okay, statement based problem. Okay, I hope for this lecture it is sufficient. Thank you, have a nice day.